Hi, this is Dale. Back to record problem 12.6 parts B and C. We had a little technical difficulty with the wrong audio somehow appearing with it, so hopefully this will fix that issue. And so again, in part B, we're called on to estimate with 95% confidence the difference in mean distance driven by male and female drivers. And we're going to use this formula, the confidence interval estimator. So we're going to take the x bar 1 minus x bar 2 plus or minus the t for alpha divided by 2 and then multiply that by the s subpar squared, which is the pooled variance estimator, times 1 over n1 plus 1 over n2. Now we've already got a lot of the numbers in place, so it's just a question of going back up to in the spreadsheet and bringing those numbers down. So the first thing we're going to do is take x bar 1. So I'm going to go up here, and remember we calculated x bar 1 right here. So it's E12 minus, in this case x bar 2 is E13. I'm going to hit check, and we see right here that we have that for 0.57. Just 1 second. So that first calculation is 0.57. Now we want the t for the alpha divided by 2, which we have just above us in cell E39. So we'll just bring that down. And again, I'm just breaking this formula down into its pieces so that it'll be easy to calculate the lower confidence level and the upper confidence level. And then we get to the square root. So it's equal to the square root of that pooled estimate right there, S30 or E30, excuse me, times 1 divided by n1. So let's go up and find n1 here, which is right here, 100, plus 1 divided by n2, which is in cell H13, and close it with 2 parentheses and hit enter, and we see that we get 0.407526. So now using this confidence interval or confidence interval estimator, we're going to calculate the lower confidence level and the upper. So we'll do that by going equal to the 0.57, and in this case it's the lower, so we're going to go minus, and then we're going to take the t right here for the alpha divided by 2 multiplied by everything in under the square root, which is right here, and that is going to give us minus 0.23. And then for the upper confidence level, it's going to be the 0.57 plus alpha times that equals 1.378. And that's it for part B. That gives us the confidence level range. Let me see exactly what it said there. Estimate with 90% the difference in mean distance. So from the lower end 0.23 to the upper end 1.7 or 1.378. And now for Part C, check to ensure that the required condition or conditions of the techniques used in parts A and B is satisfied. And basically, we're looking for some kind of normal distribution here. So, the easiest way to check that is go out and make a histogram. So, I'm going to start in cell D54, click on Data, and go to the Data Analysis pack that we added, and then I'm going to select histogram, OK, and now the input range, well, I just set this a little while ago. Again, it's the distance, but the genders are all 1, so it goes down to 101. You can see at 102 it starts 2. So this is for males, and again, output on the chart. D54 is great, so I'm just going to click OK. It created the bins and the frequency, but it always, for some reason, puts that histogram up here, so we just go up there and slide it down. We'll put it right here. Now I'm going to right click some of the data there, format data series, and I'm just going to close that width so it's all close together. And you can see right here, as far as that goes, it's a fairly normal looking distribution. I mean, it's not perfect, but it's not bad. And let's do this again for data analysis. Histogram, click OK. And right there, we're going to clear that range and come down here, and once the numbers turn to 2, we're going to start selecting those, and it'll go down to the bottom of the list, which is like cell 201. And then instead of D54, we're going to go D71. We're going to make sure the output is chart. Click OK. Created it, but it always dumps that up there for some reason. And again, we'll right click here, format data, choose no gap. And again, the requirement, and it shows that throughout the last couple chapters, basically you're looking for something close to a normal distribution, and this is sufficient to give us that. So that's 12.6 parts B and C. I hope that helps.